All right, it's on. Welcome, guys. Thanks for joining us. Always exciting to have the Lunchalytics team and the Dark Horse Analytics team running this meetup. How many of you are here at Startup Edmonton for the first time today? Oh, it's awesome. Lots of fresh faces. That's great. You came out at a perfect time because this week happens to be Edmonton Startup Week, which is something we do each year to bring more people like you out to really great events like Lunchalytics. There's lots of different activations throughout the week. There's over 50 different things going on over the 5 days this week to celebrate some tech companies in the city, to disseminate knowledge and bring together the community. So lots of really great companies to meet, a lot of them here in this building. We're doing free co-working at Startup Edmonton this week as well. So if you want to linger after the lunch hour and take advantage of that, you can check in with our team up at the front. We've got a really exciting event going on tonight in this room. It's called the Valley Tech Talk. You can register directly from edmontonstartupweek.com. We're bringing in some great speakers from Silicon Valley to talk about how you can take advantage of the resources and customers there to grow your business from Edmonton. And then the flagship event of the week that's really fun is coming up tomorrow night over at Rogers Place, just across the street from us. It's called Launch Party 8, and we bring out 10 really exciting fledgling startups, and you can come in, meet the teams, talk to the founders, demo their products in a really fun environment. It's really to help showcase what they're doing and create more awareness around them here growing their company in Edmonton. So no shortage of opportunity. I won't ramble on too much because there's a lot of stuff going on this week and we got to burn through some fun data analytics talks today. But just want to introduce Dan from Dark Horse Analytics, who is the guy you'll want to talk to if you want to come out to more or participate in more events like Lunchalytics throughout the year. So thanks so much for joining us. You can find our team throughout the space if you're interested in chatting following the event. So thanks.
Thanks, Warren. Welcome to Lunchalytics 32. I'm just waiting for are we good? We're live, we're online. So we're casting live streaming to the internet, which has a global reach of over 6 billion. A couple quick announcements. This is actually like Analytics Month. There are so many opportunities to get involved in cool analytics stuff. Today is Construction Analytics. In a moment, I'll introduce our first speaker. But first, I wanted to mention there's a thing called the OM Mixer being hosted at the U of A School of Business next Wednesday, high noon, yet another free lunch. And we'll be talking about a course that the business school offers that I actually teach, which is looking for projects. So if you have a small project that requires an analyst or someone to do some mathematical stuff with your data, this is the course for you. You pay them very little money, well, about $5,000, and you get a team of 3 students working for you like slave labor, doing fantastic work. And in the past, they've done amazing stuff that saved companies hundreds of thousands, if not millions of dollars. So come talk to me if you think you might have a project that could fit into that course. And with that, I'm going to now introduce our first speaker, who comes to us from Clark Builders, named Ian Cox, and he is going to talk about contracting analytics. Take it away, Ian.
Thanks so much. Good afternoon, everyone. I'm going to try not to block our clicker today, and no product placements. Yes, I'm Ian Cox. I come from actually the IT group, the IT project management organization at Clark Builders. And so my background, we can actually go ahead to the next slide. Background is a wall of text, but largely it's in economics. So I came to IT through an economics route. And more recently, I've joined a group that is known as Cognitive Edge, and they are largely concerned with what's known as complexity science or complexity studies. A particular slant of theirs is on anthro-complexity or cognitive complexity. So what's the complexity around the decision making we do? So that kind of dovetails in with the talk I'm going to be giving in a few moments. So a little bit about the industries I've worked in, just down at the bottom there. Actually began around the age of 16 or so in industrial scaffolding and working with industrial painters. But then that kind of made its way to where I am right now, which is largely working in IT. So what is a naive expert anyway? So it's a term that is basically used to describe someone who has a skill set that's not directly related to the field that you're talking about, but can provide some insight. So that's basically my role. I have IT and economics. I'm not really a construction person, nor am I an engineer. So I'll get that out of the way right now. And so if we can go to the next slide, please. So for, if you look at some of the research on what the challenge of construction analytics challenges are, you'll find, something similar to this list on the side, largely relating to how we don't have good data. The data is disorganized. It's inaccessible. It takes too long to get. And by the time you get the data, you analyze it and you're 3 months in. And so you don't really, that section of data that you just analyzed is now updated and no longer relevant. So that's a perpetual theme in analytics, BI, data science, the whole, well, any research really. So these are generally what you'll find as the responses to the problems. I'm not really going to talk about those. Deloitte's done a wonderful job here. So you can reference there. I'll give you the reference slide after this. You can go ahead to the next one. So the response of Clark Builders is data governance. So this is just a cross-section of some of our own data governance initiatives. I am involved in quite a few of them. My primary area right now at the moment is people data, getting good data about everyone who works for us, whether they are kind of office or field, and then managing that data in a way that you can coordinate resourcing for projects and other initiatives, let's just say. So we can go ahead to the next one. Every good research paper starts with a question. So construction's an interesting field. You basically have the option to treat it like a good and a service, right? You provide a service in your pre-construction work. For example, construction management itself is a service, and the process of contracting also a service, it turns out. So you also provide a good at the same time, however. So that's the kind of duality that you have to deal with when you're working in construction. And so in the economics world, we talk about inputs and outputs and determinants, very fascinating things. Determinants usually of supply and demand, but anyway, so next tier of that question, sorry, no, we can say here. Next tier of the question would be, is it an open system or is it a closed system? For example, I won't steal too much thunder about modular, but modular is a relatively closed system. You can almost simulate lab-like or factory-like conditions, right? However, a site operation is a lot different. It's a lot more open, and it actually starts to look more like an ecosystem than it does a factory. So the imperatives there, from a scientific perspective, would be co-evolution and exaptation are the two biology terms that would come in there. But anyway, won't get into that too much. And so systems thinking comes into play where we go, okay, is this a linear problem? Are we looking for relationships, cause and effect, or are we looking for some correlation, or is this something completely different? Is this nonlinear or stochastic or another type of problem that we're looking at? And sometimes actually systems thinking only goes so far, and then you're in the world of complex adaptive systems, or CASs. Can't get into that too much, I only have 10 minutes. So the end of the line here with the thinking around whether it's a systems problem or a complex problem is whether you can do fail-safe design, which is basically the plan and execute and close, which is our project management cycle, or whether we need to get into something different, which is something that hasn't really hit the construction literature just yet, but it's being looked into. What I'm going to talk today primarily about is the deal, and that's the nature of construction. You start with a deal, and it's primarily a contract type. I'll get into what those are. A project delivery method, so how you're going to do the project itself, and then the procurement model. So how does the owner bring this to market and basically get somebody to do it for them? So we can go to the next slide. Contract types are basically on two sides of a spectrum. I'll get into that in the next slide. But does anyone know what this formula is? Have you ever seen this before? Yeah. What? Sorry.
Profit.
Yeah, basically, this is the standard theory of the firm, right? And it's pretty simple. You have prices and quantities of things that you're selling, whether that's services or goods. Real capital costs, so you've got a minus in front of there, so it's a cost. And you've got wages and labor hours. So that's how you calculate the labor. So I'm taking some liberties here by oversimplifying this, but you can go to the next slide. So when you're looking at a contract, you have cost-based contracts, which are where you basically say, this is how much we paid for the goods that, or the inputs that were required to produce, and you're going to pay that amount plus some premium, right, a markup. You don't generally work for free. Price-based contracts are something like, you call them generally a lump sum or a fixed price contract. And so that's something that you basically say, all right, we'll do this for X amount of dollars. And then anything up to that price, you capture the profit on top of that. So you try to keep your costs low here. Over here, you want to invoice well, right? That's record keeping versus cost saving measures, let's say. Next. So what I've done in the past and am doing currently is looked at the initial conditions for a contract. And these are basically the wall of text that constitute those. I'll go through what these are. I've actually got all the formulas in there, but we'll breeze through those. If you'd like them, you can contact me. I'll give you a card. In any case, starts with an estimate. There's obviously that premium, so the markup, and you've got the contingencies and other premiums built in. There's often, in some relationships, you may negotiate a pain or gain share agreement where any profits or losses are shared among the owner and the contractor. And then you have some, obviously, the actuals, so the variation in estimate comes in when you're looking at your actuals in the end. So I'll actually buzz forward to the next one, so help out. Original estimate, again, another wall of text. These are all the things that could possibly go in. Of course, you're going to get your supplier prices. Don't underestimate that. That is only one line, but that is a lot of work. However, there are other indicators that you can use to inform how those prices might trend. So if you set up, for example, a lump sum contract in a really good market, and then all of a sudden the prices start dipping on that market, well, you've already fixed the amount that you're going to receive. If you can drive those costs down by whim of the market, then you start realizing more profit, right? That's kind of what I've heard a lot of construction companies ask, why can't we get the gains we had in 2010? Well, you just have to look at the economic conditions of 2010 in order to realize that many people got in just before the prices started dipping, and they really won the lottery there. So it's not to say that they didn't do fantastic work on top of that. It's just helped out quite a bit by the market, right? So knowing a lot about macroeconomic indicators is actually a good thing when you're estimating. So next. So mentioned markup. So these are the different contract types, and these are all derived from historical data that I have had access to either through contracting relationships with clients or companies I've worked for. So these are highly aggregated and anonymized. So I'm just going to buzz through these real quick. So this is the markup formulas for each contract type. We can go forward to the next one. Then we have contract price, and these will start flowing in together. Notice that all the letters are the same as what we had in the input slide. So next, cost of change orders, and then next, sorry, what the owner pays for those change orders. So the price, right? Going forward, profit and loss on those changes. So change orders, kind of a big deal. Pay attention to those. And then finally, so this is where the money is. So obviously for a lump sum contract, you have a lot more considerations than you would for a, let's say, a unit price where you're basically paying for, it's more like a reimbursable. So I think that covers it for that. So when you're looking at scenarios where you're factoring in all of those formulas I just had, in the slides previous, where you look at things like no underestimation, no variance in estimate, but change orders coming in at 6%, you find that, all of a sudden a GMP is a really bad idea, was a really bad idea. Now, bear in mind, you don't always have the liberty of choosing the contract type you get. The market doesn't always abide it, but you can get somewhere with negotiation if you understand the mechanics of the contract. So over here where we have an overestimate, so a negative underestimate is an overestimate, and a 6% on changes, and you find that all of a sudden lump sum is the champion, right? So this might well be the 2010 scenario that some companies were talking about, right? Maybe not. We'll have to ask them themselves. So this is just it broken out by contract type. Those are just some general contract types. So it was probably a lot really quickly. I don't know how much time I have left. I think I'm on the button, aren't I? Okay, so next slide, please. That would be a question slide. Yes, sir.
Yeah, I have a pretty loaded question.
Okay, I may have a loaded answer.
So I worked as a cost engineer at a construction company, and the issue, so what I saw working there is that you would have these sub-teams, they would all work on different projects and things like that. And then they would use like MC squared, they would use J.D. Edwards, and there would be then there would be like a tool that logs, say, hours for workers and foremen, things like that. They would use Excel to be able to do estimates, like I would say to do the analytics for the taking all of that information and somebody hand typing it in, which was myself. I kind of find that so there was a few issues. It's a little bit political in the sense that people were not adapt to the change management side. There was also these older tools and estimators, a lot of like the manual takeoff and everything. So how would you go about, say, integrating a more advanced modern analytics into sort of with these older processes, all these different like sub teams and getting everybody trained, but then being able to and also convince people that, especially the older ones, that even though you have this tool, does not mean you're going to lose your job,
right?
Because they always felt that if they're the ones who have all the insights, and if they have another tool that gives them all the insights, what are they for? So I'm just curious what your opinion is on how to integrate something like that.
So I'll answer the question with a question, which is an excellent thing to do always. Has anyone read The Invisible Gorilla? So one of the things that they talk about in that book is the role that expertise can play in what they call inattentional blindness. So the inability to see things that perhaps somebody who isn't as embedded or isn't as invested in the, let's say, steady state would be able to see. So for example, I use the term naive expertise. Some instances there were companies that used, for example, Lutheran liturgical design specialists to model their greeting ritual for the front desk of a hotel. Often you can find, well, you can find an economist sitting in a in a construction shop doing IT. So the idea of the naive expert is a good one, where you can have a third party to provide some insight that might not best come from within, right? This is often the role that consultants do play. And so this is one tool that a lot of companies will use to say, what's the word, disrupt their operation, right, in a constructive way. So that's one example I can think of.
Sure. You've got a lot of very advanced concepts when it comes to building the price models. How are you finding the uptake of these concepts amongst project managers and decision makers that don't necessarily come with that expertise or even the groundwork for that expertise?
I think it comes by packaging it in a way that's most accessible. So from this work, some of it was extracted directly from the data products that I actually produced, which were actually in Excel, because you often have to use a familiar medium in order, like if I put it into a software program, great. But then, you know, somebody's going to be looking for a user guide and how-to videos, and so the overhead of that actual initiative becomes much greater. So the opportunity to turn it into something that's, you know, as simple as let's get your takeoff estimate in there, and then we'll just aggregate those, and the formulas will flow. Right? So that's basically the way that I approached it, was creating an accessible tool.
All right, we'll have to cut off questions there. Thanks very much, Ian. I really appreciated the. Our next speaker is from PCL, Jamie Feufel. Did I pronounce that right? And he's going to be talking about a case study in construction analytics. But while he's sitting up, raise your hand if you are looking for a job in the analytics field. Looking for jobs, okay? Put those hands down. Raise your hand if you are offering jobs in the analytics field. So there we go. Look around there. And just name the company that you're with. ATB Financial. Northwest College.
United Sunman Systems. Drone company.
A drone company. Okay, there we go. So you know who to talk to. If I know Alberta Health Services HR Workforce Analytics is looking for data scientists as well. So without further ado, over to you, Jamie.
I'm going to stand over here with Dana's eye. Good afternoon. Just a brief introduction. So I'm Jamie Feufel with PCL. 21 years with PCL, mainly here in Edmonton. And I'm going to try to give you just a very quick overview of an analytics project that we have within our company. Next slide. So how many people know PCL? Lots. I guess it's not only if you look across the street or around us, there's lots of green and gold flying around. Just for those who don't, Canada's largest contractor, about 4,500 staff, employs somewhere in the order of 20,000 craft, although I think that's low because we probably got about 8,000 just in my district right now. We're in 30 centers across North America. We've got an office in Melbourne, and I asked the question. So next slide, because most people, when they think of PCL, they don't think of this. They think of what's around us, the tower cranes. This is what my district. I'm with PCL Industrial, Canadian Heavy Industrial Group, and what we do this. A little bit going on there. This is actually Fort Hills. This is Suncor. We're still there working on this. And what I'll try to draw your attention. What do you notice in this picture? What stands out very quickly?
Lots of cranes.
Lots of cranes and snow. It's coming. I guess, yeah, lots of cranes. And I guess why we have lots of cranes is that pretty much every heavy industrial project here in Alberta and in other parts of the world relies on modularization. It's as a cost savings mechanism. So I'm going to talk a little about that next. So I thought as the introduction of analytics, let's put it in form of a question. How do you set 400 modules in one afternoon? A little tongue in cheek there, but we're going to try to attempt that next. So modularization is, again, really what we refer as the backbone of our planning on these projects, because it's generally the biggest pieces go in first. And so, you know, when we're sitting there planning our jobs, it's well understood that this is how we're going to save money, be more effective, open work fronts, drive fabrication and module priorities. This is where it starts for us when we're planning. Next. And historically, that exercise is done manually. It's been done with construction engineers. We have no less than 5 of them in our group right now. And those guys and gals, they sit there and they historically had to do this on hard copy drawings, using spreadsheets and calculators. And because it's such a big part of our business, you know, we started ideating, like, how can we do this better? How does this get more efficient? And again, you know, next slide. So 10 years ago, maybe a little bit longer, we already had an existing relationship with the University of Alberta. Dr. Abarisk with the Construction Engineering Management Group, I'm sure some of you know. And using his teams and our own employees, we started ideating of how can we do this as part of our business better. And next slide. And so what has been kind of crafted over 10, 12 years is what we commonly is a suite of products that we commonly call heavy lift. And it's really an analytical solution that is comprised of these parts. And so it starts with a crane database, and I'm going to go through each of these after this slide. Cranes, you just saw them, there's lots there. We need to kind of have an understanding of what those things are and what the capabilities of them are. Lift objects, what are we actually lifting? Modules is a big thing, but so is equipment, tanks, machine bases, all kinds of things. 3D model. 3D models are pretty commonplace now. They weren't always, but they are now, and it really does. It's a visualization tool that we rely on heavily. And then, of course, the more traditional project management things, schedules. What are we working with? What are the boundaries of what we're doing? What are the sequencing that we have to respect? And then cost estimates. What actually are the prices of all the moving parts that we want to analyze? So we throw all that into some databases, and then we stick it into our homegrown simulation engine. Next. So the first, crane database. There's hundreds and hundreds of cranes out there. And interestingly enough, they can all be configured in certain shapes or forms. And so what becomes hundreds of cranes becomes thousands of capacities depending on how you configure it. Are you using a luffing jib? Are you actually, what size of, mast are you using? There's so many variables on a crane. And each time we actually change those variables, we throw it in the database. So we not only know the capacity of, what you get out of the box, but how you configure it and what those capacities bring to it. It's in a database. Next. Lift objects. What are we lifting? So that's what we're there to do. That defines the backbone. This is a project where it's predominantly, you're looking at pipe racks, which is, again, the backbone of an industrial project. The different colors actually represent the different rigging configurations that we'll require. You can have rigging configurations that are defined by 6 or 14 points, and all that really means to the layperson is how many hookups are we dealing with. So each color represents a different hookup, and that hookup is significant when we're analyzing because that change in rigging costs money. Next. 3D model. A lot of the exercises that used to be done in the past were two-dimensional, doing it on paper, doing it with a calculator. Not anymore. We do it in 3D space, and in fact, even our simulation engine, I remember, 5, 6 years ago when they were doing some of this, one of our construction engineers was reaching out to Stanford because there was a robotics algorithm that was available that they were putting on their websites to figure out how to do kind of pick and place. Well, it was for robotics, but it's the same action that we use in crane analysis, pick and place. Next. And so then we throw it into a simulation. And very simply, For those who aren't familiar with it, we mobilize a crane. That's costly too, by the way. And then through a series of steps, starting with ground preparation, and what ground preparation looks like is generally crane mats, big heavy timbers that level the ground, support the weight of the crane and what it's lifting. Assembling the rigging. Is it a 6-point lift? Is it a 14-point lift? It all changes depending on what you're lifting. We actually perform the lift. That's where the money is. That's what we're there to do. The best, that's once that thing gets in, that's opening work fronts. That's what it's all about. And then when we're done, well, do we have to disassemble it, move the crane, and start all over, 400 times. And so, next slide, or just click. What we're trying to do is optimize these parts. The least amount of ground prep, configurations, or assemblies that we have to deal with is the more optimum solution. And so you can appreciate that doing it once, probably a bit of a challenge. Doing it 400 times in 3D space is a little harder. Next. So the analysis, one of the pieces of analysis that kicks on is basically, well, what's this going to look like? So this is more of a plot plan of a given plant, same plant that I showed in an earlier slide. And what you're looking at is basically all the final assemblies that are going to be on that job. So we start with that. Next. And then we look at, well, what's the available ground space? Where can we put cranes relative to what we got to put in? And we run the simulation. And we put all those variables from the crane database, the lift objects, and the model space itself, and say, okay, well, let's start looking at this. Next. And what you'll get is actually a spread. I call this the spread. I don't know what my illustrious construction engineers would call it, but I call it the spread. That's where you can put cranes in order to install everything that you see in that plant. But we don't want to, that's not really deterministic. That's not going to tell us where to put the crane. So what do we do next? Next. That's exactly where those cranes need to be. Those are what we would say are the optimum solution to put those cranes. And so that's building on the idea that it may not be that from that location, we're not doing one lift, but multiple lifts, and it's, and doing things. So then the next slide is what crane is it? What crane should we be putting there? And so this is an example of trying to show that, if, a 500-ton crawler, big crane, is cheaper than an 800-ton crawler, right? Probably about by $30,000 a month. Kirby can answer that for us later. He's the equipment guy. But in order to do that, there's 14 setups to use that smaller crane. And with that, we have to prep 250,000 square feet of matting and crane prep. However, on the 800-ton, we only have to do 6 setups and only 165,000 square feet. So even though the crane is more expensive in the grand sum of things, this is the cheaper option. And that's just for that location to those lifts. We have 400 lifts, remember. We have to do this for all those lifts. Next. And so, some of the early indicators of what we've done on various jobs is, we've saved, we've looked at jobs where we've gone from a kind of a first glancing of 160 setups to 120. The simulation software actually produces the deliverable of a lift drawing. So all those things have to be lifted. We actually give physical drawings to our crews to actually say, here's what you're lifting, here's what you need to do. That software produces that now, as opposed to a construction engineer doing it in CAD. They're doing it out of this model. 30 hours down to 15. Schedule-wise, we had a recent project that we finished a few years back. First time we actually probably used the software, and we can, we feel that it saved us 3 months in our schedule on a 10-month schedule, a heavy lift schedule. And then last but not least, we know that, working with this, we've, at least optimized our heavy lift to a 25% savings on baseline. Never mind that probably has bigger implications because we've opened up work fronts, knocked down indirects. It's probably more than that. We're just not bold enough to say it just yet. So big reason why we do it is to knock that cost down. Next slide. So again, just in summary, how do we set 400 modules in one afternoon? Next. Obviously, we did it with analytics, right? Next. Thanks. Take some questions if there's any. Dan?
So you custom coded the simulation model and built it from scratch?
Yeah, yes. It's probably derived from some of the work that Dr. Abarisk has done. Like I know he has the Symphony simulation tool. Knowing that most of our employees come from that program in that group, I'm sure it's a derivative of that. Yeah.
And does it allow you to optimize as well? Or
It's currently at its state, and we're continuing working is more doing what if. So we get the general first pass planning of what cranes we want, and then we run what ifs to the point that that's the low cost solution. Yeah. Sorry, in the back, and then I'll come to you.
Where do you see this going next?
You know, it is right now a what if. Like you said, you kind of have to do a little bit of first principles to kind of get a couple scenarios that you want to test. But, you know, there's the challenge I've thrown to Rick Herman, who is actually the brains behind this, so I got to throw props to him, is, well, Rick, why what if? Why not just put the model in the schedules and the variables and let it tell us what the optimum crane scenarios are and how many? And so that's, you know, it's never stopped for us. So someday he'll get there. That's where I see it probably going, is really just put the variables in and then allow it to run it and give us the solution as opposed to what ifing a number of solutions. Or well, do you and then you.
Have you increased the lead time and complexity of data collection prior to building these models over what we've seen previously?
If I understand, like we are, you know, for lack of a better term, we're kind of data whores. We're always trying to get that information. And if we don't get it in the model, we will figure a way to get it. And we're very creative in how we do these things, but things that were assumed to be in a model and sometimes are not, things that may be on a classical drawing, we'll take that effort and put it into a database so it's there available to use in the analytics. So we would love to increase the lead time, but unfortunately we are the last in the chain of an EPC type cycle where we're at the, other than on a partnered project, we are at the beck and call of the engineer. And so we fight and we try to get in there early and do all that stuff, but we're not quite there as an industry yet.
My question is similar to where this could be going in the future. You mentioned that you print off the drawings from the actual program theater operators. I've heard before of the augmented reality version where, say, you have your 3D models and they're all built for the site. So say you're at this site, your operator holds up an iPad and shows them what the plan should be. Has that ever sort of been?
I think we're game to try that type of stuff in some shapes or fashions, but you know, there is a reality that there are tradespeople on the other end of this, and some of the younger generation are certainly more adept at thinking like that. But it's kind of like the naive expert. You kind of have to kind of approach these things differently for different groups. I wouldn't see this one being quite that, but certainly in our electrical group, they are very motivated to that line of thinking. They're a younger group, a more proactive group in those spaces. And in some sense, it's a less risky proposition for them than lifting, you know, big, scary modules, right?
Okay, one more question.
Now that you've developed this ability, is it something that you're going to just keep internal, or is it something you give to others or not? You give it to yourself?
Well, I mean, at the end of the day, we are contractors in competitive business, but it has been developed in, you know, jointly with the university. So there are parts through the CEM program or NSERC that are available to participants in that program. And then there's others that aren't. And certainly that crane database, that's taken us years and years to develop all that. And you know, that's not something that we're probably going to put available, at least not commercially.
But maybe for profit. Like,
never know. You know, never know. It could happen.
All right. Thanks very much. So as Jamie switches over, I told you that this is the analytics month. There's a conference called the Data Management Conference, 3rd annual. Just scroll down a little bit or click on the speakers. Coming up on the 27th. And to quote someone, it's the best little big data conference in Canada. But some of these are just great pictures, but we have a cyber security expert coming from Washington, D.C., I believe. We have Kevin Waugh from Google DeepMind and formerly at Facebook. We also have David Marco. He's the He's kind of like the guy of metadata, like the metadata guru. So people will come from all over the Pacific Northwest to this conference. It's local, and there is a special price for those who can't go to the whole event. And there's limited seating at that special price. And there's lots of certifications if you want to get certified in data management or BI or analytics stuff. There's lots of opportunities for that. And I think the way they set it up is you only pay if you pass. So you can take the course, write the test, and if you fail, then they don't charge you. So it's kind of a good deal. I don't know if they're doing that this time, but sometimes they do that. But yes, register. It's hosted at NATE, and these are kind of world-renowned speakers coming to this event. If you're interested in this stuff, go for it. All right. And our final speaker is Kirby Yakimchuk. He is from Ledcor, and he's going to talk to us about analytics on mobile equipment. Take it away, Kirby.
Thank you. That's passed the first test. You got the name right. Just want to say thanks for the invite. Gives me an excuse to wear jeans to the office. So on a Wednesday, appreciate that. So what I want to talk about is analytics on mobile equipment and really kind of the lack thereof. Next slide, please. Same question to the group. Ledcor. Who's familiar with Ledcor? You've probably seen the cars driving around for the most part. Vancouver, lots of vertical construction. So we've been around 60 years, about 6,500 employees, a whole ton of assets. My name's Kirby Yakimchuk. I'm the Director of Operations for our internal equipment group. So everything from skid steers to tugboats to airplanes, everything but essentially rail is kind of what we're into. So my group looks after that. So I get to spend money, play with the toys, and think strategically. So I really want to frame the conversation around the strategic. Not so much what we're doing today, but what I see, where I see the industry going, and some of the missed opportunities. So there's only one industry in North America that has not seen the productivity gains that everyone else has, and that's construction. If anything, 30 years ago, we were more productive than what we are today. And a lot of it comes down to client demands. We have a much larger safety conscience today than we did years ago. All of this really drives down the productivity in our business. So executing mega projects, I'm sure my peers can talk to the overruns and the challenges that go with that. So trying to bring it all together and increase productivity is a challenge across the industry. So Ledcor, within my group, we've got 2,500 mobile assets. About 1,000 of those are connected with 7 different telematics providers. So we've got everything from our TELUS contract, our little transits that are GPS up through to the big cat equipment. So we've got different telematics suites throughout the company, and really no aggregation of that data. So trying to do analytics on 7 different data sets that have a different look and feel, obviously a challenge. Saying that, North American adoption of telematics is roughly 20%. So on a couple different boards in the US, and it's a common refrain from contractors in all walks of life that it's a great tool. There's a cost associated with that tool and getting that data, but people just haven't been able to get their heads around what to do with this data. It's data, it's not information, and it's something that the industry continues to struggle with. There's a few that do it well, but for the most part, people just aren't utilizing it. That being said, we're 15 years into telematics, and prior to that, ag has been doing it for probably 25. So it's a very mature vertical. It's been there and it's existed. It's just realization of showing value to the end user is a challenge. So what's changed over the years? So the technology's really become commoditized. For the most part, those telematics modems come out of the same factory in China, and they're branded Orbcom or whatever else and resold. So you can go across the street, find 6 different telematics providers, and likely sell you the same type of stuff. It is more reliable, less susceptible to failure, in particular in the field when it comes to antennas. Data pricing is more affordable. We live in Canada, so it's typically more expensive than anywhere else, but to get that information in real time back to your database or to the cloud is much more affordable than it used to be. Cell coverage is better. You're not relying on satellite failover or anything like that. But the biggest change really has been industry acceptance and collaboration. So I sat on the committee that helped draft ISO 15143. So this is a telematics data standard. So this is just an API that sets 22 data points that all of the large OEMs have agreed to support. So it'd be your tier one OEM. So your Deere, Caterpillar, Volvo. Up until then, they've all had their proprietary data streams, and we've got a JD Link portal that we can log in and look at our John Deere equipment. We've got the Cat Vision Link that can do the same thing for Caterpillar. So we finally got everyone in the group and came up with an API or a standard that we could agree to. So from that, we've got 22 data points that also pulls in the SAE J1939, so some trouble codes along with that. So what is the opportunity? So there's a ton of telematics companies that offer analytics, but it's really based on their supplied hardware. So they provide you a modem, they can get seatbelts, obviously location, speed. It's fairly simple. Everyone can do that, and you're limited as to what analytics you can actually pull from that. Obviously, they're not pulling in the SAE trouble code, so trend analysis on some of the mechanical systems is difficult to do. OEMs in the same side of things offer telematics solution for their equipment, but only for their equipment. So you may have a fault code on a Komatsu, but if you've got a CAT supplied hardware, you're typically not getting that same stuff. That the ISO standard is meant to eliminate that. So, and really, there's only a few in the middle. Data aggregation is absolutely necessary for a large fleet. We've got 2,000 assets, multiple different portals. The only way to really take that data, turn it into information, is to aggregate that data set. Next one. So the data is being collected in multiple buckets, all of which don't talk to each other. They're done in isolation. And really for that part, they bring little to no value. So for us, like PCL and Clark, to build a business process around 7 different buckets and make it consistent is impossible. We talked about, someone had mentioned the change management aspect of disruption and data. That's probably your biggest one is trying to teach folks 7 different ways of doing things. So the opportunity for everyone in this room is the big bang. Bring it all together, put it in the cloud, and then perform your analytics. Make it simple, make it understandable and deployable to the office, to the field, so that you can action it. And that's about it. Any questions? It's kind of meant to be a bit of a Q&A thing.
Do you use any of the data that you collect for reliability analysis? And how do you...
So funny you should ask. I spent 3 years as a reliability engineer. The 22 data points as it stands right now is somewhat limited to what you can do as far as reliability. You'll need typically larger data set. There's ways to go about getting that real-time information and logging it and doing that. So to answer your question, we don't currently, but we struggle from a contractor perspective in doing so. We don't have a standard base of operations. We're moving around all the time, and connectivity is always a challenge. But for the mine sites, definitely, they take the reams of information, they can really boil it down to a predictive analytics. And I've seen it in person in some of the oil sands mines.
Aren't your field operators able to judge the equipment better than the computers can?
Yeah, and I think that was some of the challenge of the early systems, in that you're designing a telematics solution to push an alert up over cellular to an office that needs to be actioned and then back down to the operator. So I think early on they lost sight of really who's in control of that machine. It's the operator. So you need to have the proper elevation within the cab and the proper information within the cab so that those folks can make the decision. So a low oil alert, by the time it gets to your office and back out to the field, the engine is toast. So you need a way to communicate directly to the operator meaningful information so that they can make the right decision. So either shut the machine down or a corrective action at that point. But really, your operator is your first line of defense. Your telematics is there for your trend analysis, either through reliability, trends in production mapping, fuel burn, that kind of stuff. It's really not meant for that kind of on-demand, instantaneous decision-making. Did that answer your question?
Not really.
Okay. You want to elaborate, maybe?
Well, I'm just wondering why you're bothering to do this at all.
The analytics?
Yeah.
So the opportunity from that is really, with any mobile equipment, is to decrease your overall cost of production. So you can decrease
Overhead. You added a whole bunch of overhead.
to the rate.
Overhead, is it worth it?
Well, and that's why we had see 20% adoption. Till you can really see value and pull that information up and execute it to decrease your total cost of ownership. That's why your deployment is still at 20%. That's why we don't have a consolidated system to do that. We're much more refined on the vehicle side because we do see visible decreases in fuel. The heavy equipment really can be driven strictly by utilization, but we haven't been able to get our heads around what that impact to the total cost of ownership is as of yet.
So you're like the laser. You're looking for a problem to solve?
We're looking to decrease costs, but it's got to be the right tool to do so.
Well, the older people tell me I was a lot more efficient, got a lot more done before we got all these computers.
And that's in a lot of ways, for sure, right? I think ultimately where it's going to go is to autonomy. It'll skip right through telematics and machine autonomy will be where it goes. Field deployment of drones.
Like, with all these brains in the room here, how come we haven't found a solution that can make money?
That's why I don't have the answer here. This is for everybody in this room. Oh,
So have you looked at driver safety or off-site use of vehicles?
Yeah, so we do have some client requirements for driver safety. And again, it becomes a tough one to quantify, in particular around the net total cost of ownership. But there are some metrics out there that we can use, and that's primarily why the bulk of our deployment is on-road vehicles. Dispatch, really route management, when you start getting to the heavy equipment side of things, is a bit more difficult. Sorry, there's one more back over there.
I'm actually curious about like your IoT structure with the cellular to the cloud. Do you do you have that cloud infrastructure in-house, or is it like an external platform?
It's all third party at this point, and when we do aggregate, it'll probably remain third party. Just more of our comfort level with our internal resources than it is anything else, but it can likely sit anywhere. And I think you're the drone guy, right?
I'm the drone guy.
TopCon Trimble, there's lots of push from the big data perspective to aggregate. So there's lots of suites out there where we can push data into. Our business is moving dirt, building buildings. It's not hosting a cloud. So.
Yeah. So this is not a question, but maybe just a feedback question from there. The past couple of years, we've been implementing telematics. We actually
Speak louder.
in the last couple of years, we have been implementing telematics, and firsthand, we saw the benefits of that actually, like based on evidence. It did reduce the number of heartbreaks, meaning like reducing the near misses of possible accidents and so forth. It did.
Glad to hear that.
What's that?
Glad to hear you did.
Yeah, it showed that the reduction in the fuel consumption, obviously because you're keeping the speed in check, and it actually allowed us to defer some capital investment in the new vehicles as well too. So there was actually like evidence-based benefit of the implementation of telematics.
Yeah, for sure.
All right, one more question.
Yeah,
back over there.
so that includes like the adoption of telematics in North America. So it's 20%. Is it for all industries or just construction?
That'd be primarily construction. That's yeah. And obviously with FedEx, UPS, they've got your delivery, your supply chain guys typically have better deployment, and the on-highway stuff is much more refined, but the construction side continues to lag.
All right. Well, thanks very much. Appreciate the talk. I know one way I saw this being used was when an owner gets a bill for the heavy equipment working on his site. He can look at that and say, okay, and I'm looking at the telematics and it says you only worked 15 hours, but you billed me for 20. And it's a good way to audit the billing if necessary. Next month is Workforce and HR Analytics. I just decided that right now. And it's November 15th, high noon. We'd love to see you there. If you know anyone who can speak to those topics competently, come talk to me. We have no speakers lined up yet, but I'm sure we will. And lastly, I forgot what it was. So thanks very much for coming to Lunchalytics 32. We'll see you next time.